Hello everybody and welcome to Algo Expert. In this video, I'll be covering the question of array of products. Now before we dive in, let's make sure we understand what the question's asking of us and the input and output structure. So for this question, we'll be given one input, this input will be an array, and this array will contain integers. Now what we're being asked to do is return a new output array that is the same length as the input array, where every element in the output array contains the product of all other elements in the input array. What I mean by this is if we're looking at position 0 here, and we can reference position 0 in the output array as well, the output array should contain the product of all elements except for the element at position 0. So the product of 1, 4, and 2. So 1 times 4 times 2, that is equal to 8, and that is why 8 is sitting at position 0 in our output array. Now let's go through the rest of the values here to make sure this is clear. So if we're talking about position 1, then this should contain the product of all other elements except for the element at position 1. And so we get 5 times 4 times 2, which gives us 40. That is why that is at position 1 in the output array. Moving on to position 2, we can see that we are going to have the product of 5, 1, and 2. That is 10. That is why we have 10 in the output array. Finally, moving on to position 3, we have the product of 5, 1, and 4. That is 20, and that is why we have 20 in the output array. So that is what we are being asked to do. Now, one small note here is that you are not allowed to use division when solving this problem, and that the output array that you return must be a new array. It cannot be the same array that was passed in. So in other words, you cannot modify the input array. So with that said, that's all I need to discuss for this problem. Now let's talk about how we can solve it. So as we start talking about the solutions to this problem, the first thing that I'll note is that there's many different ways to go about solving this, and in this video, I'll show you 3 different ways. Now we're going to start by going through the brute force approach. This is the non-optimal solution that runs in the worst time complexity, and then we'll get into 2 more optimal solutions that work a little bit differently. So let's start with the brute force approach. I just want to move this array upwards a little bit to give myself a bit more space. And actually, I'm going to label all of the indices as well, just so we can reference them as we go through here. All right, so the brute force approach to this problem is pretty straightforward. This simply involves using a nested for loop, so a for loop inside of another for loop, to calculate the value that should be at each position for every single one of the positions that we have. And so what we're going to do is set up 2 iterators here, one iterator I, one iterator j. Now j will iterate through all of the values for every value of I, and so what this will lead us to is an n squared time algorithm, and you'll see how this works in 1 minute. Just to quickly state here though, if you were looking at this in code, you would see something like for I and then in, and maybe we can just say n for now to keep this simple. And then inside of this for loop, you would say for j in and then n. And here what we're going to be doing is looping through all values of I in n. And then for every value of I in n, we're looping through every value of j in n again. And so that's what's going to lead us to the n squared time complexity. But I will go through that time complexity after we've walked through this solution. And so we have our 2 iterators, I and j, and what we're going to be doing is setting up some variable here, and we'll call this product for now, that will store the current product that we've calculated as we're kind of going through each iteration here. And so I starts at 0, j starts at 0, and the first thing we're going to do is to check if I is equal to j. Now, if I is equal to j, we're not going to do anything, and the reason we're not going to do anything is because we do not want to add this value to the product that we are trying to calculate. And on that note, the product variable is going to start at 1, and every single time we move I, we'll reset this product variable. Anyways, we've just checked if I is equal to j. I is equal to j, and so there's nothing that we do in this step. What we're going to do next, though, is we're going to move j over, because now j has considered position 0. Now it needs to move over to 1. All right, so now we check if I is equal to j. I is not equal to j, and so what we can do is multiply this product by whatever the value is at index j. In this case, it is 1, and so the product's going to stay the same as 1. Now we're going to move j over. J comes over here to index 2. We check, is I equal to j? No, it is not. And so what we do is we multiply our product by the value that's at index j. In this case, that value is 4. That means our product is going to change here to be 4. Now we are done with that step. We move j over. J comes over here to index 3. This has a value of 2. Now what we do is check, is I equal to j? No, it is not. And so what we do is multiply 2 by our current product. So product multiplied by 2, that is going to give us the value of 8. All right, so now we have calculated the product that should be at position 0, and we have finished looping through all of the values for our kind of j for loop, so for that nested for loop. So what we'll do is we'll reset j back to the beginning, and then we will simply insert this product of 8 into a new array that we are going to create, or would have created before, at position 0. And so we can imagine we have this kind of output array up here. I'll just write it a bit smaller, and the very first element in our output array is going to be 8, because that is the product of all other elements except for the element at position 0. All right, so now we will continue, and we will move I over by 1. The reason we move I over by 1 is because we've now calculated the product for index 0 or position 0. Now we want to do it for position 1. All right, so now we're going to reset product back to 1 because we've just moved I over, and now we will continue the process again, except I is at position 1. So we check, is I equal to j? I is not equal to j, and so what we do is multiply our product, which starts as 1, by whatever this value is. In this case, it is 5. There we go. Now we're going to move j over. J now moves over here, so it's at the same index as I. Since these are on the same index, this means we don't need to do anything. We're not going to multiply our product by this value. Instead, we're just going to move j over one more. J now moves over here. We see that this is not the same index as I, and so what we do is multiply our product by this value right here, which is 4. And so our product now becomes 20. And then we move j over again. J now comes over here to this last value. We see this is a 2. I is not equal to j. And so we multiply our product by 2. That's going to give us a product of 40. And now j's done. We're going to reset j back to the beginning because we finished that iteration. We now have a product of 40. This is the value that we need to insert in position 1 in our output array. And so we go ahead and do that. We insert 40 right here in our output array. Now we reset the product back to 1, we move I over, and we continue the process again for this next index. So now we start iterating through j once again. We see that j is equal to 0 and I is equal to 2. They are not the same, and so we multiply our product by whatever this value is. This value is 5, so we put 5 right here. We then move j over, j moves over here. I and j are not the same, so we multiply our product by 1. Well, 5 times 1 is just 5, so I'll leave it the same. We then move j over. J is now equal to the same index as I, and so there's nothing we need to do here. We do not want to add this value to our product. Now we move j over once again. We see j is not equal to I, and so we multiply our product by this value. This value is a 2, and so what that gives us for our product is a 10. We have now finished iterating through j, so we can reset j. J can go all the way back here. We can now add our product to the output array, and then we can move I over. We can reset our product back to 1, and then we can continue the process for the last position of the last value we're trying to calculate. We see that I is not equal to j, and so we multiply our product by this first value, which is 5. Let me write this in the correct color, so that's 5. We then move j over. J is not equal to I, so we multiply our product by 1. Obviously, 5 times 1 is still 5, so we just leave it the same. We're going to move j over again. J now becomes equal to index 2, which has a value 4. That's not the same as I, and so we multiply our product by 4, so that gives us 20. We then move j over to our last position. We see that I and j are the same, and so we do not do any multiplication here. Now we are done. We simply add 20 to our output array. Again, let me just write this in the correct color. We then reset our product back to 1. We would then move j all the way back to the beginning, but now I is completely done. We've looped through all of the values, we've filled our entire output array, and so we're actually done with this algorithm, and now all we need to do is simply return this output array that we have created. And well, that concludes the brute force approach to this problem. So as I was saying, this approach runs in a big O of n squared time complexity. The reason this takes n squared time is because we loop through all of the values of n being the length of our input array. So we loop through every single value in our input. And for every single one of those values, we then loop through all of the values once again. And so for every value in our input, and we have n values in our input, we are doing n more work. That n more work is coming from that nested for loop, and well, n times n is n squared, and that's where we're getting our n squared time complexity from, the fact that we have those nested for loops, and for every single value in our input, we're looking through every single other value. So that is the time complexity of n squared, and then our space complexity is pretty straightforward. This is just going to be big O of n. The reason we have big O of n is because we need to create this output array. This output array will contain n elements, n again being the length of our input array, and so we're going to use n extra space. And so that is going to conclude our brute force approach. Again, time complexity of big O of n squared and a space complexity of big O of n. Now let's move on to some more optimal solutions. So I've just cleared the screen, and now we're going to start getting into some more optimal solutions. Now, before I do that, I just want to quickly state that if you were given a problem like this, it would be highly recommended that you first go through the brute force approach, so what we just did, and then look at that brute force approach, analyze it, determine where there's some inefficiencies, and then use that kind of hint or use what you've discovered in the brute force approach to help you come up with a more optimal solution. That's exactly what I recommend you do in a coding interview. First, walk through the brute force approach, explain why this is not the most efficient way to solve this problem, and then use that information to help you come up with a more optimal solution by kind of realizing where you're doing some repetitive work and where you can optimize the time complexity. So for this problem here, when we looked at the brute force approach, what we should have realized is that the reason we were getting that non-optimal time complexity is because we were doing a ton of repeated work. Because we had that nested for loop structure, that involved us doing a lot of multiplication, multiplying two numbers together that we had already multiplied before. And so in this solution here, what we're going to do is avoid doing that by storing multiplication that we've done already. By doing this, we'll avoid any repeated multiplication and be able to solve this problem in a linear time complexity. So to show you this, I'm first just going to move this example up a bit so I have a little bit more space. And I want to show you how we can come up with a product that should be at a specific position, say position 1, by looking at the product of all of the values to the left and all of the values to the right. So if we're trying to calculate the product that should be at position 1, really what we want to do is multiply the product of all of the numbers to the left of position 1 and all of the numbers to the right of position 1. So if we take the product of these two values, which is 8, and we take the product of this value, which is simply 5, and we multiply these together, that's going to give us the number that should be right here, because that is the product of all of the values, excluding the value that's at this position. And we can see 5 times 8 is equal to 40, which should be at that position. Now, this holds for all of the other values as well. If we're looking at, say, index 2, this is equal to whatever the product of all of the values to the left is, multiplied by whatever the product of the values to the right is. And in this case, that's 5 and 2. We know that that is 10, and well, we can see 10 is at that position in the output array. And so what we're going to do here is we're going to try to determine the product of all of the values to the left of a specific index and the product to all of the values to the right of a specific index. And then we'll use those two values, multiply them together, and that will give us the value that should be at each index in our output array. So what I'm going to do here is start by creating two kind of empty arrays, or we'll start by initializing them all with the value 1. So we'll have our left array and our right array, and I'll discuss exactly what these arrays will hold and do. So this will be our left array, and this will be our right array. Now, the idea behind these two arrays here is that at some position, let's say position I in our left array, we want to have the product of all of the values to the left of this position in the input array. So if we're at position 1, which is what I is at right now, then we want to have the value 5 here. The reason we would want to have 5 in this position is because that is the product of all of the values to the left of position 1. Now, if we moved over to position 2, which would be right here, we would want to have another 5 here because 5 times 1, that's the product of all of the values to the left of position 2. Then finally, if we move over here to position 3, what we would want to have here is 20. The reason we want to have 20 is because this is the product of all of the values, so 5, 1, and 4, that are to the left of this position. So anyways, let's just fill in all of these values, and I'll show you how we actually would kind of fill in this array or complete this array. So what we're going to do is create a variable. I'll just call this again product. This variable will start being equal to 1, and then we'll have some iterator I, and we'll loop through all of the values in our input array. So in fact, let me put I up here. So I is going to start at position 0 in our input array, and what we're going to do for every iteration is we're going to start by simply inserting whatever the current product is into the left array at whatever position I is at. So in this case, 0. So we see product starts off being equal to 1. Well, we already have a 1 here in our left array at position 0, so there's nothing that we need to do. But now, in the same iteration, what we're going to do is multiply our product by whatever the value is at this position. In this case, it's 5. And so our product now is going to become 5. Now what we're going to do is move I over. I will come over to the next position, position 1. So just like before, what we're going to start by doing is inserting whatever the previous product is into the left array at whatever position I is. So in this case, at position 1, we're going to put the previous product, which is 5. Now we're going to multiply the product by whatever the value is at I. In this case, it's 1, so the product stays the same. And then we're going to move I over. Now we're over here, I is at position 2. Same thing, we're going to insert whatever the previous product is into the left array at this position. So we're going to put a 5 right here. We're then going to multiply our product by whatever this value is. This is 4, and so our product now becomes 20. Now we're going to do the same thing. We're going to move I over. We're now going to insert 20 here into this last position. Then we're going to multiply our product by whatever this value is. In this case, it's 2. So 20 times 2, that gives us 40. However, I is now done, so we have finished filling in this left array. And if we look at this array, this is telling us the product of all of the values to the left of whatever the position is in this array. So that is correct. We've now filled in the left array. Now we're going to do the exact same thing, except in reverse to fill in the right array. So let me just erase this product here. Let me clear it and reset it back to 1. And now let's put I at the end of the array, because this time we want to fill in the right array, which means we want the product to the right of every element. And so we're going to do this in reverse. So again, product starts at 1, I starts at the very end, and we're going to start filling in the right array from the end of this array. So in this case, the first thing we do is we take whatever our product is and we insert it into this position, position I, in our right array. So 1 is already there, so we don't need to do anything. We are then going to multiply our product by whatever the element is. In this case, it's 2. And so our product becomes 2. So now we're going to move I over. So I will move over here to position 2. Same thing, we're going to insert whatever our product is into the output array or into this right array. So in this case, we get 2. We're now going to multiply our product by whatever this value is. So this is going to give us an 8. Now we're going to move I over. So I comes over here to position 1. Now we're going to do the same thing, insert our product. So in this case, it's 8 at position 1, and then multiply our product by whatever this value is. In this case, it's 1, so we just leave it at 8. All right, so now we're going to move over to the last position. So I moves over here. We're going to insert our product, which is 8, into this position. We're then going to multiply our product by whatever this is. So this is going to give us a value of 40. But now I is done. We moved I through all of the values in our input array. We now have our left and our right array that have been created and are storing the values of whatever the product is to the left or the right of a specific index. Now what we're going to do is use this left and right array to create our output array. All right, so let me just clean up the screen a little bit here. I'm going to erase that product. I'm just going to move my left and my right array over, make it a bit smaller so we have some room. And now we're going to start creating our output array. So same thing here for the output array. We can start by initializing it with a bunch of 1s. So we have 4 1s right here. Now what we're going to do is loop through our left and our right array at the same time. And we're going to multiply the values at the corresponding indices here to figure out what value we should have in our output array at a specific position. Because again, remember, in the left array, we're storing the products of all of the elements to the left, and in the right array, we're storing the product of all of the elements to the right. So that means if we simply multiply these two values together, that will give us the product we should have at this specific position in the output array. And so we'll have some iterator I here. I'll just put it over here. We start at index 0. So what we're going to do is reference the values at index 0 in our left and our right array. So we get 1 and 8. We're going to multiply them together and put that product at this position. Then we're going to move I over. I now moves over here to position 1. Same thing, we're going to reference index 1, so we get 5 and we get 8. We're going to multiply those together. We're going to get a value of 40. Let me write this in the correct color. And then we're going to move I over. I now moves over here to position 2. We reference again position 2. We see that we have 5 and 2. Well, that is going to give us 10. And so what we do is write 10 in our output array and then move I over to the next index. Now I is over here at position 3. We see we have a 20 and a 1. So we multiply those two values together. That gives us a 20. We have now created our output array. We can simply return this output array, and well, that's going to be the answer to our problem. And you can see that this output array matches with our correct answer. And there you go. That is how you solve this problem with this approach. So to quickly recap, all we're doing is creating this left and right array. So the left array is going to store the product of all of the elements to the left of an index. Right is going to store the product of all of the elements to the right of an index. We're then going to take the corresponding indices in the left and the right array, multiply them together, insert those in the correct position in our output array, and then return that output array. Now, as I said, this solution runs in a time complexity of big O of n, and the space complexity will be the same as our previous solution. We will have big O of n space. Now, the reason we get big O of n time is because every step we did here only takes us n time. So the first two things we needed to do was create this left array and create this right array. Now that simply takes us n time to create both of these arrays. So we have n plus n. That's the amount of time it took us to create the left and right array. Then we need to create this output array. Creating this output array takes us an additional n time. And so we get n plus n plus n. So in total, we have 3n time. And when we talk about big O notation, we don't care about the constants. So we can simply remove this 3. That gives us a time complexity of big O of n. Then we get the big O of n space from the fact that we have this external space. So we have n space for the left array, n space for the right array, and then n space for the output array. By the same logic, we have n plus n plus n, 3n. We remove the 3. And there you go, we get our big O of n space. So that is solution number 2. Now I'm going to show you a slight modification to this solution that actually allows us to use a little bit less space. It won't be a better space complexity overall, but we can avoid having this left and this right array and actually do everything in one external array. So let's clear the screen and have a look at how we can do that. So I've just cleared up the screen, and as I was saying before, what we're going to do in this solution is avoid having both a left and a right array and only have one single extra array. In this case, it will just be the output array that we'll kind of modify throughout this solution. So in the same way that I was saying earlier, where we should look at the brute force approach first, realize kind of where things weren't very efficient and where we were doing some repetitive work, and then optimize that to come up with a better solution, we're going to do the exact same thing here. So in the previous solution, we had this left array, and we had this right array, and then after we created both of these arrays, we simply multiplied all of the values together. Now, the thing is, we don't need to do this in so many different steps. We created the left array, then we created the right array, and then we multiplied the values in the left and the right array together. How about we just create one array? That array will start by containing what we would consider to be the left array contents. Then as we generate what would be in the right array, let's just multiply the left array by that value. So let me show you what I mean. So let's just imagine that this left array actually already exists. So we say left equals, and then our left array would look like 1, 5, 5, and then 20. Okay, so now let's say we're going and we're creating the right array. So we have some index I, we're going to have some product. So we'll say product is equal to, and then that starts equal to 1. Now, when we were creating the right array, the first thing we did is we just inserted the product into the right array. So this time, rather than inserting it into the right array, we're going to multiply it by whatever's at the corresponding index in the array that we already created. We're calling this left, but really this will be the output array. So here we're going to multiply 20 by 1. That still gives us 20, so we can just leave 20 there. We're then going to multiply our product by this value, so we get 2, and then we'll move I over. So now I is over here at position 2. Same thing, we would have inserted 2 into this right array. Rather than inserting it, let's just multiply it by whatever's already in this existing array. And so that's going to give us a 10. We're then going to multiply our product by whatever's here. So this is going to be a 4, so that gives us 8. And then we move I over. Now, same thing here. We would have inserted 8 into this position in the right array. Rather than doing that, let's just multiply it by whatever's already here. So in that case, it's going to give us 40. And then we're going to take our product and multiply it by 1, so it just stays the exact same. Now we move I over, and same thing. Take our product, which is 8, and just multiply it by whatever's here in this array. That gives us an 8, and well, now we've actually created our output array. So really, by doing this, we were able to skip one step. That step was creating that right array, and then multiplying the right array by the left array. We avoided doing all of that by simply using the logic and saying, okay, well, if all we're going to do is take what's in the left array and multiply it by what's in the right array, then let's just do that in one step. We don't need to do this in 2 separate steps. We can just multiply the values that are already in our existing array by what we would have inserted into the other array. And so now we have one array. That's all we need to use to solve this problem. This is our output array. We can go ahead and return this, and well, that solves the problem. Now, this solution runs in the exact same space and time complexity as the previous solution. So we get big O of n time, and we get, again, big O of n space. Except this time, we're doing one less loop, so there's one less step, one less bit of calculation that we need to do, and there's 2 less arrays that we need to use. because in the previous solution, we had the output array, the left and the right array, whereas in this solution, we're just going to have one array. You could call it the left array if you want, but really this is just going to be the output array, and that's all the extra space that we need to use. So no, we're not getting a better big O notation, but if you actually look at the efficiency of this algorithm, this is slightly more efficient because of the fact that we're using less space and we have one less kind of loop that we need to do through all of our values. So with that said, that is going to conclude this conceptual overview. Again, we had three solutions. The first solution was that brute force approach. The second, we had the left and the right array. And in the third, we were doing the exact same thing we did in the second solution, except we were able to avoid using all of that extra space. So now let's see how we can implement these solutions in the code walkthrough. So I'm here in my code editor, and I have my array of products function defined, which has one input parameter called array. Now we've got three solutions to code out, so I'll start with solution number one, the brute force approach, then move on to the other solutions. So I'm going to begin by defining my output array. I'm going to say products is equal to, and then we'll initialize this with ones for now. So 1 for underscore in range, and then this will be the len of the array. What I'm going to do after this is I'm going to loop through all of the values in my input array, and then I'm going to set up my nested for loop structure and determine the product that we should have at every single position in our output array. So I'm going to say for I in range, and then this will be the len of the array. Then what I will do is define my running product variable. So running product is equal to 1. Then I'm going to say for j in range, and this will be the len of the array again. The first thing I'll do here is check if I is equal to j. So I'll say if I does not equal j, then what we can do is say running product multiplied equal by array at index j. So if I and j are not the same, then whatever our running product is, we'll multiply it by whatever the value is at this position j. Then finally, once this for loop is done, we'll say products, and then this will be at index I is equal to, and then running product. Let me just move that up. And that's actually going to conclude this algorithm. So then after that, we can just return products. So let me just quickly run through this. We're initializing our products output array, filling it with ones to start. We're then saying for I in range, the len of the array. We're going to define our running product for every single time we loop through I. So at every iteration, we redefine this variable. We then say for j in range len array. We're checking if I is not equal to j. Only in the situation where I is not equal to j are we going to multiply whatever our current product is by the value at this position. Then once we are done looping through j, we're going to set the product that we just calculated at position I in the output array. Then finally, we'll return the output array. So as a reminder, this solution runs in big O of n to the exponent 2, so n squared time, and this solution takes big O of n space. So now we'll move on to solution number 2. I'm going to comment this out. I'll copy the function definition. I'll move down here. And now we will start coding out solution number 2. Now for solution number 2, we'll actually start with the same first line. I'll just copy this. So products is equal to, and then 1 for underscore in range, the len of the array. Now we're also going to do this a few other times. 1 for the left array. So we'll say left, and actually not array. We'll say left products. And then we will say right, and then this will be products as well. So what we've just done is we've initialized our output array. We've then initialized the left products array and the right products array. And now what we can do is start filling the left products array and filling the right products array. As a reminder, in the left products array, at every index, we're going to be calculating what the product of all of the elements to the left of this index is, and then kind of the opposite for the right array. So let's start by filling the left array. I'm going to say left, and then running, and then this will be product is equal to, and we'll start this equal to 1. We'll then say for I in range, and this will be the len of our array. And what we will do is we will start by inserting whatever the current product is at index I in the left products array. So we'll say left products at index I is equal to, and then this will be left running product. Then we will say left running product multiplied equal by whatever the array at index I is. All right, so after this for loop is done, we will have filled in the left products array. Now we need to do the same thing for the right products array. So I'm going to say right and then running product. This is going to start being equal to 1. Now we're going to say for I in, and this will actually be reversed, and then range of the len of the array, because when we're filling in the right products, we need to start from the end of the array. So we'll reverse this range. Now, in a similar fashion, we'll do the same thing we did with the left product. So we'll say right, and then this will be products at index I is going to be equal to whatever the current right running product is. So right running product. Then we're going to say right running product multiplied equal, and that will be by whatever the array at index I is. Now we've completed the left and the right products array. We can use these arrays to actually create the output array or fill in the correct values in our products array. So what we're going to do now is say for I in range, and this will be the len of the array. And then here, what we will do is say products, and this will be at index I, is equal to, and then we'll multiply the product at index I in the left products by the product at index I in the right products. So left products at index I multiplied by right products at index I. Now that actually concludes our algorithm. So here we can simply return products, and then that will be our solution. So let me just quickly run through this. We start by initializing our output array, our left and our right products array. We then fill in the left product array, fill in the right product array, and then finally we use the values from the left and the right products array to fill in the output array, and then we return it. Now, as a reminder, this solution runs in big O of, and let me just tab this back here, big O of n time, and this takes big O of n space. So now we have completed solution number 2. What we can do now is move on to solution number 3. Now, solution number 3 will be almost identical to this solution. So I will copy all of this, comment all of it out, and then move down here and paste this. And what we'll do is just modify this so that we can actually remove the left and the right products array and have it so that we are actually doing all of these operations simply on the products array. So what I'm going to do is remove both of these arrays here because we no longer need them. We will leave this kind of the way that it is, except rather than having left products, we'll simply make this equal to products. So now, rather than modifying a separate array, we're just modifying the products array that we will eventually return. Same thing here for right products. All we'll do is change right products to be equal to products like that. And then we will make this actually a multiplied equal rather than equal. This is because we want to take whatever value is already in the products array, so kind of the left product, and multiply it by whatever the right running product is. Then what we can do is remove this last for loop here, return products. Well, that actually concludes this third solution. So let's quickly run through it. Again, we're initializing our products array. Once this is initialized, then what we're going to do is calculate the left product. We're going to insert that into this array. So we have our left running product. We go through just like we did in the previous solution. And this time, rather than modifying a separate array, we're just modifying products at I. Then once this for loop is finished running, we will have all of the left products inside of here. Then what we'll do is calculate the right products, but rather than storing them in a separate array, we will simply modify whatever the right product is by the value that's currently in this array. So products I multiplied equal by right running product. So this allows us at the end of our algorithm to just return this products array because this contains our answer. There's nothing more that we need to do. Now, as a reminder, this solution runs in the same space and time complexity as the previous one, so big O of n time and big O of n space. So that is going to conclude this code walkthrough and this video. I hope you found this helpful, and I look forward to seeing you in another AlgoExpert question.